Good morning, everyone. Very good morning. Good morning. How is everyone? How are you all doing? How is everyone?
Good morning, ma'am.
Good morning. Namaskar. So you all people must be practicing in a good way, right? Must be doing questions in all three subjects, physics, chemistry, and maths, if I'm not wrong. Keep on doing more and more questions, like whatever things are happening in your class, you should not leave it to the class only. You should carry to your notes. I mean, you should practice some more questions from that topic also. You must be having previous year questions booklets now. So try doing more and more number of questions. Practice means questions you have to do more and more so that your hands may get free, right? What's the thing that we need to carry to the exam hall? Not only knowledge, that fear should not be in our head. Fear of solving the question. Oh, this question is too long. How to solve it? Let's leave it. No, that fear you need to crack in your home only. And that will only come if you are solving questions so many. So you need to solve the questions. Here we solve actually, but again, you need to do more done. Because here we have only 1.5 hours. And in that hours, I'm trying to give my best. Then let's get started now. It's already 3 minutes past, 2 minutes past of 10, so we can start. Yes. So I have already said that I will be discussing some of the questions of ray optics in such a way that will cater to you the basic concepts or deep concepts of ray optics that is actually necessary for solving questions. Done. So the very first question that I'm going to give you is from mirror, but that will look like a lens silvered on one surface. I want you to first try it for some 2 minutes. After that, I will be discussing in length what concept applies here. Okay. So nothing to worry about. Question is here on your screen. Take 2 minutes of your time and try it. Okay. Do it now. I've given you 2 minutes. Well, 2 minutes is over. Why I gave 2 minutes? Because you just needed to use the formula if concept is clear. Done. So let's discuss it. Nothing to worry about. Let's discuss it here. So you all know mirror formula, right? What is the mirror formula? 1 by V plus 1 by U equal to 1 by F. So we just need to apply this formula given object distance is given 20 centimeter, focal length is not given. Then why mirror formula we are going to write here? Kishore, a little bit change we need required in your answer, but you tried, it's very good. Let's see now. So we will be treating this system. This system looks like what? This is a plano-convex lens and it is silvered at one end. So roughly, if I'm going to make the diagram, what will seem like? First, suppose light is falling on this surface like this. So at this surface, what will happen? Medium is changing, it will refract, and then it will fall on this plane surface. And this plane surface is silvered, so it will act like a plane mirror. It will reflect the light, something like this. Again, here light will see a medium change. So again, not 40. Let's see. So again, what will happen? Again, it will refract. So at two surfaces, it is refracting. And one surface, it is reflecting. Then, and what significant change you can see here? Just say you have a studied lens, right? What happens in lens? If it is a lens, then if light is falling like this, it will go on to the second side. Then, so light will refract to the second side. But here what is happening? Light from one side is falling on the lens and it is coming to the same side. This is only possible if the system is acting as a mirror. Then, because we have studied if this is a concave mirror and if light is falling like this, it may go on like this. So on the same side. Then, so if light is coming to the same side, it means whatever system is given in our question is acting as a mirror. So this is acting as a mirror. So what one basic thing you need to carry in your head is when any lens is silvered at any one face, it acts as a mirror. It no longer remains as a lens. Why mirror? Because it's sending light to the same direction. Done. So this whole system, this plano-convex lens silvered at one surface is acting as a mirror. Now, of this mirror, we need to calculate the focal length. Then that is our basic work here. So how to calculate the focal length? We already know what is the power formula for a lens. If lens is given and you need to calculate the power, P equal to, you write 1 by F. Similarly, we can define power for mirror. And power for mirror is written as -1 by F. Then power for mirror is written as -1 by F, whereas power for lens is written as 1 by F. Then that we all know. Now, what we are going to do here is, see here, this hole is acting as a mirror, I have said you. So for whole system, now I am going to write this was just the general formula I've given. So for whole system, power of mirror will be equal to, so now you just try to see how many times it has refracted. How many times it has refracted? 2 times, one at this point, another time at this point. How many times it has reflected? 1 time. Done. So this power of whole mirror will be double the power of lens, because refraction thing is happening because of lens characteristic of this system, and reflection thing is happening because of the mirror characteristic, right? So 2 times refraction, it means double the power of lens we will be taking, plus power of mirror dash. That's why, because whole, for the power of mirror, like if whole system is a mirror, then for that power I have written as PM. So for this mirror, power I am taking as PM dash, just to differentiate. Done. So this basic formula we are going to write, this you need to know how to write. How you will write? You will first see how many times it is suffering refraction. So if it is suffering refraction n times, you will be writing n into power of lens. And if it is suffering reflection n times, yeah, m times you say, then you will be writing here m PM dash. Done. And this whole will be equal to power of the system, that is the mirror. So power of mirror. Done. Power of mirror you can write as -1 by F, equal to what you will be writing? You will be writing 2 by F, because power of lens formula is 1 by F. Done. Plus सॉरी इसको F1 ले लो just to avoid the confusion. इसको F2 and this is again power of mirror, so 1 minus 1 by F3. Done. Now we simply need to write the values. So F1 we don't know, focal length of this system we don't know, but focal length of the lens we know. Plano-convex lens is given in the question and its focal length is how much? 15 centimeter. Again, remember, this is a plano-convex lens. Convex lens it is. So its focal length will be positive or negative. What it will be? Positive or negative? It will be positive. Then this is a convex lens now. So its focal length will be what? Positive. So what you are going to write now? You are going to write here as 2 by 15 plus 1 by minus 1 by focal length of this plane mirror will be what? Infinity. So this is this. Now what the value of 1 by F1 we are going to get? Minus 2 by 15. So this is minus 2 by 15. Now we know the focal length of the system, that is a mirror. And this is how much? 15 by 2. Minus 15 by 2 with proper sign convention. Now apply this mirror formula. Calculate the image distance. So what you are going to do, 1 by V, image distance we have to calculate. 1 by minus 20 equal to how much? 1 by focal length, that is minus 2 by 15. So 1 by V equal to how much? This is 1 by 20 minus 2 by 15. So if I am going to multiply it with 4 and this with 3 just to simplify the calculation. So what we are going to get? Minus 5 by 60. So how much V value we are going to get? Minus 12. Minus 12 means how much will it will be? 1. It is acting as a mirror. Yeah? I told you now, it is acting as a mirror. It will act as a mirror because our light is coming to the same side as that of object. You can see here, now this is object. Had it been a lens, in lens what happens? Light will fall on one surface of lens, refract from another surface to the another side. But here, because of the silvering, light is coming back to the same side as that of object. So definitely this is acting as a mirror. I told you, if you are silvering a lens, it will act as a mirror. Simple thing is that. And for that mirror, you have to calculate the focal length. How you will calculate the focal length? You will simply consider system as a mirror. Then you will write power of mirror will be equal to power of lens. So how many times you will be taking the power of lens? That times by up to the times it is suffering refraction. Done. So here it is suffering refraction 2 times. That is why I have written 2 into PL. Suffering reflection 1 times. That is why I have written power of the mirror 1 times. Which mirror? This mirror. Not the whole system acting as a mirror. Done. Sorry. Clear है? Once. Is it clear? I hope it is.
Yes,
so
ma'am.
B equal to minus 12. Okay, done. So B equal to minus 12 centimeter. So minus 12 centimeter means image is getting formed as the same side of the object. Done. So correct answer will be what? 12 centimeter to the left of the system. Left of the system means on the same side of the object. So I hope this concept is clear. It will be coming into use if you get the question. If you remember in NCERT, ray optics, I guess last question is that. So I will suggest you all to do that question after class is over. Okay? Ray optics ka NCERT, open the NCERT, additional exercises, last question. That also involves this concept somewhat. Done. There is another question on your screen. Again, I'm going to give you some 2 minutes only. Solve it and let me know. Yes, Tejas. Very good. Prati, see the geometry properly, I will suggest. Yes, Rawat. Whenever you are solving questions of ray optics, go for drawing the diagram because you may go wrong otherwise. There is high chance of that. Okay. So, what the question was, there was a ray of light, incident light direction is this, and reflected light direction is this. So, what I'm going to do is my favorite work. First, I will draw the normal, I will draw the incident light, and I will draw the reflected light. So, this is my incident light, and this is my reflected light. So, it can be solved in two ways actually. If you look at the incident ray direction, so incident ray direction, let's treat it as a vector. So incident line vector is this, reflected line vector is this. So if we are going to calculate angle between reflected light and incident light, actually by vectorial method, it will be giving me this angle, not this angle. Done. So we should not get confused in that. Those who are getting 60° as the answer, they must be doing this way. Then you must have calculated an angle between incident and reflected, and you must be thinking like, oh, that is angle between incident and reflected, so angle will be this. No, this won't be the angle. Vectorially, if you look at incident light direction is here, reflected light direction is here. So vectorially, if you're going to calculate the angle, that will give you this angle, not this angle, right? So like blindly, if you want to solve it, you can just calculate the angle between these two vectors. And if two vectors are given, angle calculation is very easy. I'm going to say this is vector A and this is vector B. So what you will do, A dot B equal to what you will write, mod A mod B cos theta. So A dot B value will be how much? Half I dot half I. So it will give us half. And again, what is root 3 by 2 j cap minus dot minus of root 3 by 2 j cap. So how much value we are going to get? We are going to get 3 by 2, 3 by 2 done. So this is mod A value will be how much? Mod A value, if you're going to calculate, it will be 1 and mod B value will be 1 and this is cos theta. So cos theta is how much? This is minus half. So theta is how much? 120°. So this is your 120°. Now, if this is 120°, you can easily see this will be your 60 and this will be your what? This will be your 60. So if this is 60, this is going to be 30. And this is angle of reflection. So angle of incidence will be how much? This also be 30°. So what the question is, the angle of incidence is. So angle of incidence will be how much? It will be your 30°. Done. So this way you can solve it very easily by drawing the diagrams and looking carefully at the geometry, right? Second thing that you can easily do also is, you can think like here, just look at the diagram just look at the vectors that is given here. Incident vector is what? I plus root 3 j cap. And here what is happening? I minus. Which is getting minus? Which direction is getting minus? J cap. Done. So, like if this is the plane surface, this is the normal. So what happens? Incident light is this, reflected light is this. So for both incident and reflected, that x direction remains same. Y direction is changing. Initially, incident light is directed downward and reflected light is directed upward. Done. So reflected light changes its direction along the normal. Done. So from here, the equation we can easily see normal will be along which J. So normal is J, incident light is given. So one vector is this, another vector is J cap. So you can calculate angle between incident light and J. That will also give you directly the 30-degree value. Done. So you can go both. I hope it is clear. Done. चलो किसी को डाउट हो तो मुझे बिल्कुल बताना. Now mirror में I have included 2 questions. Next day I will be including more questions. I wanted कि daily we should go through different topics in ray optics. Done. That is why just 2 questions. Now let's come to this portion, refraction through plane and curved surface. Done. So just a little bit of revision I will go through. So for curved surface, you have already studied that if there is a media, suppose in our space, there are 2 different medias present. So, and this is N1 and this space is N2. And these 2 medias are separated by curved surface. Done. So, if there is an object kept here, its image will get formed in the second media. Suppose observer is here, you are sitting somewhere here. So to you, this object will look like what? It will go here, it will suffer refraction, and to your eye, image will, object will seem like it is coming or the light is coming somewhere from there. Then, so something like this happens. You already have studied such thing. What the formula for this is? So mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. Now, what is this mu2 by v? So this was the object distance from the surface. Object was like this. And where the image is getting formed, this is getting formed somewhere here. Done. So this is your v. Now N2 is what? Or mu2 I have taken here. Mu2 is what? Is the media in which image is getting formed. Mu1 is what? Is the media in which object is kept. Mu2 minus mu1, you understand? R is what? Radius of curvature. Again, you have to use this equation with proper sign convention that you already know. Done. Now the important thing here is refraction through plane surface. Then from that portion, so many questions we get. So what is that? Suppose there was, again, there is a 2 media and that is separated by plane surface, not the curved surface. Done. And just a very famous example that everyone used to give is, suppose there is a pond and there is a coin kept at the bottom. So, and if you are somewhere here, your eye is somewhere here, you are looking from the top, then this coin won't appear at a depth t, it will appear somewhat uplifted. Done. Again, here you should know how to draw the ray diagrams. Why it is appearing uplifted, not shifted more downward. Why it is that? So you need to learn how to draw the diagram, and you should draw the diagram in every question that you will be getting ahead. Done. That is important. Again, I'm just going to put the formula here, how to use that wisely. Okay. So how much distance it will get shifted up by what distance? That's the question here. So you just see what is the real depth of this point. T. So I used to write like this: real depth by apparent depth. Because formula now we should remember by some logic. So here what will happen if observer is sitting in N1 media? So if I am the observer and I am looking at something, then how it is possible? It is only possible if from that something light is coming to my eye. Done. So if this person is able to see the coin, it means light is moving from where to where? From point to eye. Yani ki light movement, just notice the light movement. That is very important for using this formula. So light movement is happening from where to where? From N2 to N1. Done. So that I used to see actually in every question, and then I write light. Light is moving from N2 to N1, so I write like N2 by N. Done. So I use the formula like real depth by apparent depth equal to jahan se I just try to see from which media light is moving to where. Done. So if it is from N2 to N1, I will write N2 by N1. If it is from N1 to N2, I will write N1 by N2. Done. So this is the way we use the formula. Again, this is for distance. Then if velocity is asked, how we will calculate the velocity? So again, it's very simple. We have already learned in our mechanics that if displacement value is given, if displacement thing is given, like if x is equal to some at square plus bt, then how we calculate the velocity? We differentiate it with respect to time. Done. Same thing we have to do here. So x real by x apparent equal to how much? N2 by N1. So if we have to calculate the velocity, just differentiate it with T and also differentiate it with T. So what you are going to get? Real velocity by apparent velocity will be N2 by N1. Same relation you are going to get, right? So these two things or three formulas we will be getting ahead in our questions. So that is why I discussed. Now let's go ahead with question. So this is your very first question. I'm again giving you some 3 minutes this time I'm giving you to solve it. Once, but here we don't need to calculate velocity now. Anyway, why you need it right now? Okay. Real height by apparent height was what? Equal to refractive index of the media from which light started traveling to the media where light is traveling. This was the formula, no? Check once more, Pravit. आप फिर से एक बार check कर लो, please. Do check once more. So this is the formula, no? Real and apparent. Done. So how you need to write the velocity? Simple. Differentiate with the time. So H real will become V real. H apparent will become V apparent. And that will be equal to N2 by N1. Everyone done? चलो ठीक है. चलो मैं explain करती हूँ. So what the question is, there is a container and that is filled with water. Water up to a height of 33.25 centimeter. Then now what is happening? A concave mirror is placed 15 centimeter above, as you can see here, and there is an object, an image of an object placed at the bottom. Object is placed at the bottom. It's formed 20 centimeter below the water level. An image is formed finally at what? 25 centimeter below the water level. The focal length of the mirror is. So what will be the focal length of the mirror? So first thing is just try to see here why the question is getting complicated. Question is getting a bit different because there is a length of water column kept just above the object, and that is why the question is getting a bit trickier. Then, so what? How we have to solve this complication? How we have to remove this complication? Just now we have seen. Suppose there is a mirror and there is no water column. An object is here. Done. So what you will do? Object was in this distance was how much? 33.25 centimeter, and this distance was 15 centimeter. So you will say the object distance is 33.25 centimeter plus 15 centimeter. Then that will be the object distance if air is throughout, but here there is a water. So this 33.25 centimeter is not going to be taken as 33.25 centimeter. It real depth is this, but apparent we will have to take now. So how we will take the apparent? For taking the apparent, just see how the light will travel. Light direction is important, I have told you. So mirror is here, object is here, mirror is going to form the image. So definitely light will travel from object to the mirror. Very simple. So light is traveling from mu equal to 1.33 to air at this interface, 1.33 to 1. Done. So light movement is from N2 to N1, 1.33 to 1. So I'm going to write H real, that is 33.25 divided by H apparent, that I don't know. Light motion is happening from 1.33 to 1. So H apparent we are going to get 33.25 divided by 1.33. Again, if you're going to solve it completely, divide it perfectly, you will be getting as 25 centimeter. This will come as 25 centimeter. Then you can divide it. Done. So this thing you are going to get. So apparent depth of this object is how much? 25. So this distance will act as a 25 to the mirror. So total object distance, if I'm going to write, you will be 25 plus 15. And that is how much? That is how much? That is your 40 centimeters. So object distance is how much? 40 centimeters. Now, before blindly using the formula, let's see what the image distance is given. So image distance is how much? This is 15 and this is 25. It is given that it is formed 25 centimeter below the surface of water. So total image distance, if I am going to write, so V will be again 40 centimeters. It means object distance is equal to image distance. This happens only if the object is kept at the center of curvature. Done. So center of curvature पे object रखा है, then only image distance and object distance will be equal, right? So U is nothing but equal to our radius of curvature, that is your 40 centimeter. So what will be the focal length? It will be 20 centimeter. Because it happens to be R by 2, right? So this will be your correct answer. Then, had this not been the case, then what we will do? We will simply, U is given, V is given. We will use the mirror formula, 1 by V plus 1 by U equal to 1 by F. And from there, we will get the answer. Done. So if water column or some other media is kept between object and mirror, if not the same media is present, object distance you need to take carefully, apparent distance you need to bring into account. And how you will do that? That I have shown here. You won't say ki 33.25 plus 15 you will write initially and then apparent depth you will take. No, apparent depth you will only take for the length of column in which water is present. Then that's it. I hope it is clear. Anyone having any doubt? If not, I will move ahead. Chalo. कोई reply नहीं दे रहा, it means there is no doubt. You are free to ask whenever you are stuck. Again, now I am just going to give you some 2 minutes. You must be now familiar with the formula. You must be able to use it now. So do it. Right or wrong, doesn't matter. You are attempting. That is my target. Chalo, karo. 2 minutes. Once this doubt is for which section? This question or previous one?
Previous one.
अच्छा, previous one. You कैसे लिया हमने? I just showed you ना. जैसे let me clear a bit here. You just see what the object distance is here in this case. This is the object now. This is object and this is mirror. So object distance will be this. If throughout the medium is same, object distance will be 33.25 plus 15. But throughout medium is not same. Here medium is air. And in air, real and apparent depth will be same because refractive index is 1. Then for water column, apparent depth will be different. Apparent distance and real distance will be different. Real distance is 33.25. Apparent, we need to write. Done. So object distance will be what? 15 centimeter plus apparent distance for this length. Done. So apparent distance for this length, I have written here 33.25 real by apparent. Light is traveling from this media to this because light will fall from object to the mirror. So 1.33 by 1. Apparent is this by this, 25. So object distance will be 15 plus 25 centimeter. Clear?
Yes.
I hope that is clear. Chalo, do this question. Done hai? I hope it is done. Chalo, more 30 seconds I'm giving. Yes, Ravit. Done. Everyone go with the diagram as well. I will suggest diagram making will help you a lot in the processes ahead. That will boost your confidence. That will let you see how things are happening. Okay. So just see here what the thing is happening. There is a ball dropped from a height of 20 meter above the surface of water. So let's form a lake. So this is a lake. Done. And there is a ball and it is getting dropped from here. Then this height is how much? 20 meters. Now, who is looking at the ball? Refractive index of water is given, that is 4 by 3. And there is a fish. There is a fish inside. So let me, I have drawn a fish like an eye because fish is the observer. A fish inside the lake in the line of fall of ball. In the line of fall means normal incidence is there. Then normally it is looking at the ball. And all the formulas that we have dealt with is for the normal incidence, right? You already know that. A fish inside the lake in the line of ball is looking at the ball at an instant when the ball is 12.8 meter above the water surface. So suppose ball is here and this distance is how much? 12.8 meters. It is asking that at this instant, what will be the velocity of this ball with respect to fish? Means to fish, the velocity of ball will appear as what? Done. That's the question. So had the fish been air, if fish is in air, then it will see the velocity of ball as it is. And what will be the velocity of ball at this point? If we go on calculating pure mechanics, if we apply, so from 20 meter it was dropped. How much distance it has traveled? It has traveled 20 minus 12.8, and that will be how much? 7.2 meter. So 7.2 meter it has fallen. What will be its velocity? So if you're going to use the equation of motion, v square equal to u square plus 2as. So v square, velocity at this point, we don't know. So v square, u square dropped. Dropped means initial velocity is what? 0. So this is 0 plus 2 into displacement and acceleration I'm taking in the downward direction. So I'm taking downward direction as a positive. So we can write 2 into 10. Then I'm taking g, s equal to 7.2. So how much v value we are going to get? This is 72 into 2. So that is 36 into 4. Done. So this is going to be how much? 6 into 2. That is 12 meter per second. So originally, what is the velocity of ball at this instant? 12 meter per second. But since fish is in water, its velocity will appear to be different to the fish. What will be its velocity? That is our task. Because calculating pure velocity was not a difficult task. You can easily do it. If a ball is dropped and it has traveled 7.2 meter, what will be its velocity? It's very simple. Now, what will be the velocity according to fish? So we need to apply that real and apparent wala scene. So what we will be doing here, let me make a column. So first write H real by H apparent wala formula here. So H real by H apparent will be what? Let's see, light will travel from which to which direction. Who is the observer? Fish. So fish is the observer. If fish is observer, light must come to the eye of fish from the ball. So light will travel from ball to fish. Then only fish is able to see the ball. No? If light will travel from ball to fish, then only. So light is traveling from 1 to 4 by 3. So here we will write 1 by mu. Again, the same relation will be valid for the velocity. So here I will write real velocity by apparent velocity equal to 1 by mu. Done. Real velocity is how much? 12. Apparent velocity, I don't know. 1 by mu. Mu is how much? That is your 4 by 3. So 3, 4 times mein chala gaya. V will be equal to how much? 16 meter per second. So that is 16 meter per second. So the answer will be what? C. So if questions are not happening, that's not an issue. You are learning, and after class will end, you must pick some 10 questions from all the topics together and you must try solving this. Okay? That will serve your purpose. Chalo, okay. Again, I'm giving here you some 3.5 minutes. Okay? Chalo. So do this question. Read the question carefully first. Draw the diagram on your copy and try using the formula. Question is very easy. Do it now. Anyone has any doubt, then you can put the doubt in the chat box. Pravit, yes. Oh no. Prithvi, you need to reconsider your options. See the geometry carefully. I feel like in calculation you have done mistake. Pravit, it's done. Very good. You people are trying. You people are solving. This is good. What happens to other? Isor, Keshav, Saurav, Tejas, Tripti once. And one more is Som, Hariom. Chalo. Let me know the status of you people. Everyone is trying now. Yes. Prithvi once, no idea. Okay. Okay. I just want you all to try. Even if you're not getting the answer, if anyone is thinking like, what will happen in 1 month? But yes, something can happen and something big can also happen if you have really studied in your 11th and 12th, and if you have honestly given your GMINs, then rigorous practice can help you. I'm telling you, it's quite possible. Then, so what I want you to do now, every question you just try at your level. Even if you're not getting the answer for now, for every chapter, while I'm dealing with the chapter, flow with me in the sense, try solving the question. Not getting the answer, no issue. But if you have used the formula, if you have given it a thought and tried, it must have given you something. It must have added some value to your understanding, right? And after the class, you should take some more questions and try solving. This way, you will be able to do, right? When you will reach the exam, you will be able to, I am telling you, it's very much possible, 9-10 questions you will be able to crack. Done. So you need to put a belief on yourself, and also you need to put the labor, you need to put the hard work. That is very important. So don't shy away from doing the work. कि यार ये तो हो नहीं रहा, करने का क्या मतलब है, क्या हो जाएगा 1 महीने में, 1 minute, you know what happens when earthquake comes from some seconds, it shakes the whole world. It can just collapse the whole world in 1 or 2 or 3 seconds. So what matters is intensity. How much intensely you are doing your work, so you can do. Done? चलो ठीक है, बहुत motivation हो गया. Now let's solve this question. So what the question is, there is a object, I guess this object is P, and that is kept at a distance 50 centimeter from the first curve surface, right? And there is another glass tube kept here at a distance D away, and medium is different or same. S1 and S2 both are having same refractive index 1.5. And what the question is, object is initially at 50 centimeter, but what is happening when it is going through the second tube, it is becoming parallel to the principal axis. It means finally image is getting formed at infinity. So it is asked that what will be the distance between these two tubes. Done. So simple, what will happen? Object, light coming from the object will first refract by the first curved surface. Done. So first curved surface will form object somewhere. That object will act as an, will form image somewhere, and that image will act as an object for the second curved surface. Done. And that will finally form image at the infinity as given in the question. So chalo, let's do what is, let's apply the formula at the first curve. So what is the formula for curved surface? Refraction mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. Now, in first case, object just to figure out mu2 and mu1, just see object is in which media. So object is initially in which media? 1.5. Done. And its light is getting refracted into which media? Light is getting refracted into refractive index of media 1, air. Done. So mu2 here is what? 1. Mu2 here is what? 1. Because this is image distance, so we have to take the refractive index of media in which image is getting formed, in which light is getting refracted. So that is your 1. So here I will write 1 image distance. I don't know. Minus object is in 1.5 media. So 1.5. Object distance is 50 centimeter. Will it be taken as positive or negative? So see here, curved surface is like this. Incident light direction is this. Measurement will happen from here, 50 centimeter in this direction. So definitely it will be negative. Done. Centimeter only I am writing mu2 minus mu1. So 1 minus 1.5 R. R it will be taken as how much? 10 centimeter. Again positive or negative. R will be measured something from here to here. So again it is negative minus 10. So this is my very first equation. From here I can calculate what B. So can anyone tell me very fastly what will be the value of B here? So 1 by B, chalo मैं कर रही हूँ, but you people also do it. This is your 1 by 20 minus 1.5 by 50. Then something like that. So it will be 1 by 20 minus this is your 3 by 100, I guess. 3 by 100. Done. So if I'm going to solve it, my favorite task is to make the numerators, denominators same. So this will be 2 by 100, I guess. So V is going to come as what? It is going to come as 50. Then if I'm not wrong, this is 50. Then so this is 50. Now what will happen? Again, refraction will happen at the second surface. Then refraction will happen at the second surface also. Like image is getting formed somewhere at this point, and this light will again cross this curved surface. Done. So again, are you getting me or not? Are you understanding? Second times refraction will happen. Suppose कर लो, चलो मैं एक diagram बनाती हूँ. Suppose कर लो, something like this is happening. It got like this, and if suppose there is no first surface, there is no second surface, sorry, there is no second surface, and image is getting formed. Suppose this is 50 centimeters. Suppose I am saying, then, but since there is an image here, this light must have got refracted here also. Then, so final image will get formed somewhere here, not here. That is why we need to consider refraction to the second surface. Now for second surface, which will act as an object. Again, I am saying ray diagram is very much important. So from first surface, image is getting formed here. And if you can see the second surface carefully, incident light on the second surface is which? This one. This is the incident light. So incident light appears to meet here. It means this will be its what? Object distance. This will be what? Object distance. And this is the refracted wala light. So this is the image distance. Correct? Samajh rahe ho na? So this is my logic. So incident light for the second surface is in medium 1. And for the second surface, refracted light is in which medium? 1.5. Then again, I am going to use the formula. Now what will be the formula? Mu2 by V. चलो ठीक है, फिर से लिखने का इसको कोई जरूरत नहीं है. mu2 by V. So mu2 by V के लिए what I will be writing? mu2 will be what here? 1.5. V I don't know final image. चलो इसको V dash बुलाती हूँ. Minus mu1. mu1 is how much? 1 by U. Sorry. Final image is getting formed at infinity. Now that is given. Just for clarity, I've drawn the diagram like this. But finally, ray of light, refracted ray of light will become parallel because it is given that finally image is getting formed at where? Infinity. So V dash is known now. This is infinity. Minus 1 by U. चलो U ही लिखते हैं इसको. Equal to mu2 minus mu1. How much it will be? mu2 minus mu1 will be 1.5 minus 1. R. R for our sign convention, what should I take? Positive or negative? Anyone reply fast. What should I take? Positive or negative?
Positive.
Just let
Positive.
me. Yeah. Positive it will be because incident light direction is this. Very good. So this is 10. Now this will become what? Minus 1 by U equal to how much? 1.5 minus 1. That is how much? 1 by 2. Done. So this is your 1 by 20. So U is coming as what? U is coming as minus 20. So object distance was how much? From here it was how much? Minus 20 means somewhere here object must have been for the second surface. So that is 20 centimeter. Done. And for first, according to the first case, image was getting formed at where? 50 centimeters. So from here it was 50 centimeters. Done. So this image formed by first surface was only acting as an object for the second surface. So for second surface, object distance 20 centimeter, and for first surface image distance 50 centimeters. Both the objects are same now. So what is the distance between these two surfaces? 50 plus 20. So what will be the answer? 70 centimeters. So as you can see carefully, question was not difficult. You just needed to apply the formula at two surfaces with proper sign convention. Done. In the first case, object distance was given, and in the second case, image distance was given. Done. So this is over. किसी को doubt है तो let me know. Otherwise, we are good to go with another question. किसी को doubt है for 30 seconds? I'm stopping here. No, I guess no. Very good. Chalo. So this is your next question. You have to calculate the value of D. What is D? You just figure out. Read the question carefully. I'm giving you some 3 minutes. Okay? Read the question carefully. Do it. हाँ किशोर बोलो. कुछ डाउट है क्या? अच्छा डन ना. पॉजिटिव आर मैंने कैसे लिया? हाँ सेकेंड केस में. एक सेकेंड रुक जाओ सारे लोग. डन है. चलो फिर से मैंने डायग्राम को क्लीन कर दिया. देखो डाउट जरूर पूछ लिया करो. इफ यू आर नॉट आस्किंग द डाउट, यू आर कैरिंग डाउट विथ योरसेल्फ एंड दैट विल. अच्छा ठीक है. बट आई नो अबाउट द इंसिडेंट लाइट डायरेक्शन ना किशोर. जैसे लाइट was traveling first, object was this, light got refracted here, and this refracted light is falling on the second surface. That is for sure. So for second surface, this is the incident light. Done. And while taking sign convention, the incident light direction is taken as positive. So for second surface, this direction is positive and this direction is what? Negative. Done. And its radius of curvature will be somewhere here like this. Done. So you are measuring from here to here in this direction. Now, incident light direction is taken as positive. Done. In sign convention. And if you are measuring a distance in the direction of incident light, then that will be taken as positive. And your radius of curvature we will measure in the direction of incident light only. So that is why I took in the second case radius of curvature to be positive. I hope it has answered your doubt. Is it clear? If anything else is also there, you can let me know. I can explain. Even if image is getting formed in the second rod, Kishore, even if image is getting formed in the second rod, it doesn't matter because we have to see the direction of incident light. Suppose image is getting formed, as you said, image is getting formed in the second rod. So for the first case, still I have not taken into account refraction for the second surface. Okay? So just forget the second surface for now. And it got refracted like this, and it is meeting at the x-axis somewhere here, suppose. So, and now if I am bringing the second surface here, again see the incident light direction is what? This one, na? Then this is the incident light direction for the second surface. And for this, in this case, this image will act as what? This image by the first surface will act as an object for the second surface. And this object will be what? Virtual object. Concept of virtual object you must have studied, right? Virtual object is what? The object at which incident light seems to converge. डन. अगर आपने पढ़ा होगा, सपोज करो इंसिडेंट लाइट इज कन्वर्जिंग समवेयर. So if incident light is converging somewhere, it means that is an object, and that object is a virtual object. If I'm keeping a surface here, refractive surface here, or if even if I am putting a mirror here, so for this mirror, incident light is this only, na? And these incident lights are meeting at a certain point. So this is the object. जैसे what is happening? चलो मैं फिर से थोड़ा सा और एक्सप्लेन करती हूँ यहाँ पे. You just see the case here. Virtual object का case आएगा जो आप पूछ रहे हो. So what will happen? Suppose this is a mirror. Done. And what is happening? Light is coming from infinity and it is meeting, it is falling on the surface. So this light seems to come from infinity. Where is the object? It's not visible here now. So what we can do, we can extend the incident light. And if we're extending the incident light, it will meet somewhere here. So this is your virtual object. Done. So this is the virtual object. So object will be taken as a positive here because object distance you will measure as this now. And this is in the direction of incident light. So here object distance is positive. Here also radius of curvature of the this surface, if you are considering as a refractive surface, its radius of curvature will be taken as positive. Then same thing is happening here. If object is getting formed here, then definitely this light will not cross this surface. No? It will come here and that is appearing to come here. If second surface would not have been here, and because of second surface, light is going like this. Are you getting me? Is it clear? Done. Thank you. Doubts you should not carry with yourself. Okay? Chalo, do this question. I've given you 3 minutes. Read it carefully and do it. Chalo, do it. Is it done? Question is not difficult actually. It could have been over till now. How you people are solving actually? What the question is given? There is a particle here, no? This particle is just at the top of this water surface, and there is a mirror 5 centimeter down of it. Done. And it is asked that there is an observer just here. So to this observer, image of this particle will appear at what point? Done. That is the question. So if you look at carefully, this mirror is kept where? In the water. Object is kept where? In the water. So no question of apparent depth here for calculating the object distance. So object distance is what? 5 centimeter. Then what is the focal length given? Radius of curvature is 40. So focal length will be 20 centimeter. Done. Now what we are going to do? We are going to calculate its image distance. So 1 by V plus 1 by U equal to 1 by F. Use the proper sign convention. Object distance will be considered as negative. Focal length will be taken as what? Object distance is how much? Oh my God. Object distance is 5 now. And its focal length we are going to take as what? Positive or negative? Focal length is
negative.
Yes. So it is negative. Now what is the V? Minus, this will become 1 by 5 minus 1 by 20. So how much value we are going to get? We are going to get 3 by 20. So what is the image distance? If the observer is at here, not in the air, but in the water. So if observer is just here, so it will see that image is getting formed some 3 by, image distance is how much? 20 by 3 plus, so plus sign means image must be getting formed somewhere here. That is your 20 by 3. The virtual image is getting formed, right? So 20 by 3. Now, if observer is here, image distance will appear at what depth? It will appear at H real, I'm saying. It will appear at what? 5 plus 20 by 3. But what is the problem here? Problem is observer is not sitting here. It is sitting in the air. So if observer is in air, this distance will appear as what? That's the question. So very simple now. How you will solve it now? Chalo, do it fast. Let me know what will be that apparent distance. Jaldi se.
मैम इमेज हमारे टम्बलर के बाहर बनेगी?
नहीं बाहर नहीं बनेगी. दिस इज अ वर्चुअल ना, ये वर्चुअल है ना 20 by 3. So this is not in real. So obviously inside water only, but virtually it will seem like it is 20 by 3 centimeter beyond the mirror. Then so beyond the mirror doesn't mean it is coming in the air. It is coming in the water only, because my mirror is kept in water only. ठीक है. जैसे यहाँ पे apparent concept को you need to consider very carefully. जैसे if this is the mirror and if my object is kept between focus and pole, then image gets formed somewhere here now, somewhere here, and this is a virtual image. This is not in reality. So in whatever medium this mirror is kept, in that media only this virtual image will get formed. Done. So this 20 by 3 centimeter downward, again, media we will be taking as water only, not air. Okay, yes, correct, Saurav. Thank you. Okay, so it is clear what I said. So H real, okay, done. H apparent will be equal to how much? This is equal to light is traveling from where to where? Observer is here now. So light must come from object to the observer. So light must travel from water to air. So water refractive index is how much? It is 1.33 by 1. So H apparent will be how much? H real, that is 5 plus 20 by 3. If we are going to solve it, this will be 11.67 something, and that divided by 1.3. So if you're going to solve it, definitely it won't be 11.7, it won't be 13.4. It will be either this or this. So if I'm going to divide it, it will be close to 8. So C will be your answer. Okay. If you want to practice such questions more, in HC Verma it is given, some 3 or 4 questions are given. But enough I have discussed in your class. You can just pick the previous year question and you can solve. Okay, chalo. Again, I'm giving you some 3 minutes. What you need to do here again, not a complicated question. Read the question carefully. Write the formula properly with proper sign convention. That is all you have to do here. Do it. Okay, so previous question may you understood how to use the formula? Rest people do the question that I've given. Just Kesav has a doubt. Yes, so you know the formula, na? So this was how much? 1.33 was there, na? So H apparent we needed to see, right? Really at what distance image is getting formed? From here 20 by 3. So from the top 5 plus 20 by 3. So that was the real distance of image. 5 plus 20 by 3. That is equal to how much? 6.67 something, right? This is the no, that is your 11 point something. Done. So this was the real distance of the image, but since observer is in air, so real distance of image by apparent distance of image will be equal to what? Let's see, light is traveling from where to where. So light always travels towards the observer. Then, so observer is in air. Towards the observer means light will travel from water to air. So I have written refractive index of water in the numerator and that of air in the denominator, because as I have discussed in the formula, you have to write the refractive index like what? Like from which media light is traveling to which media. So it is traveling from water to air. So refractive index of water will come in the numerator and that in the denominator. Got it? Okay, chalo. Thank you. Do it. I hope everyone is trying. Chalo, done. Let me discuss again. So what you need to careful about here again, that's the same. So there is a thin film of uniform thickness and refractive index 1.4. So its refractive index is 1. Chalo, I've got an answer. Yes, one is correct. Another one you needed to calculate. Huh? Chalo, very good. So this is 1.4. Now, here also, there is a thin film kind of thing here, N2. And what is happening? Ray of light parallel to the axis of cylinder traversing through the film. So ray of light that is incident on the first outward surface of the film is parallel to the principal axis. Means light is coming from the infinity. Yani ki object is at infinity. Done. So this is happening. To glass get focused at distance f1 from the film, and this light get focused at a distance f1 from the film, where while rays of light traversing from glass to air gets focused at a distance f2 from the film. And again, when light is traveling from glass to air, so this thin film is like a transparent thin film of uniform thickness. This was coated on a spherical surface of radius r at one end of a long solid glass cylinder. This is a solid glass cylinder now. So what will happen? First, light is traveling from air to the film of refractive index 1.4, and then light will travel from 1.4 refractive index media to 1.5. So these two things are going to happen. Done. So at one surface, what is going to happen? First, you have to use the formula, right? So at first surface, object distance is what? Infinity. So object media is what? Always choose object media by looking at incident light. Done. So for first curved surface, incident light is in which media? Incident light is in refractive index 1. And where is your yes, Tejas. And where is your refracted light for first surface? In which media? It is in 1.4. Done. So for first surface, if you are going to use the formula mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. This question I will be just giving the information. You will be solving it, because solving each and every is not going to help. But yes, logic I want to give here. So for first diffraction through first surface, my image distance is v, and this is the refractive index of the media in which light is getting refracted. So that is 1.4. तो यहाँ पे आप क्या यूज करोगे? 1.4 by v minus incident light media, that is your 1. So 1 u value you will be putting. So mu2 minus v1, again you will be calculating, and r ka sign convention. So what will be the sign convention for first surface? Incident light direction is this. So this is positive for first surface, and its r will be also in this direction somewhere. Done. So that will be positive. Again, you need to use the formula here. Now for second surface refraction. What?
बट मैम इमेज तो हमारी N2 में बन रही है ना, तो हम रिफ्रैक्टिव इंडेक्स भी वहीं का लेंगे.
But I am talking about the first surface. Still, I'm not talking about the final image. I'm talking about first surface diffraction. Hello?
Yes, ma'am.
Yeah. Who is this speaking? Can you tell me your name, please? Just for the information, I want name. No, nothing wrong about it. I just wanted to know the name. Okay, once. Okay. So done है ना? So first surface refraction के लिए I wrote it. Now for the second surface, what you will see, again let me make it more clean actually. So what will happen here? What will happen? Light coming from the first surface. Jay, image distance is infinite for what? For which surface you are talking? For which surface you are talking? No, first surface के लिए object distance is infinite, no? Just read the question now. Rays of light parallel to the axis of cylinder traversing through the film from air to glass get focused at a distance f1 from the film. ray of light traversing through the film from air to glass get focused, matlab ray of light is parallel to the principal axis. Now, light that is falling on the first curved surface is coming from infinity. Now, so how you're taking image distance as infinity? Jay, how you're getting this doubt? You just let me know now. चलो बताओ. Yes, Prithvi. Good. Jay, is it clear? Done. Okay, done. So for second surface, similarly, I'm just guiding you through the refractive index wala clarity. So on second surface, what will happen? Incident light is which? This one. So incident light is in which media? 1.4, and refracted light is in which media? N2. So N2 is what? 1.5. So for second surface refraction, mu2 will become 1.5, mu1 will become 1.4, and incident light ka direction is this. So properly you will be using the sign convention and getting the answer. So you need to solve this question. I want you to solve this. Okay, I've given you enough information. Now you will be able to do. So many people have done it. Everyone else will also be able to. Chalo, done hai. So this is one more question I want to discuss is from total internal reflection. Again, this is a very common question. It has came in 2014 also, and it has came in some 2018 also in some different way. But again, the concept was same. So I'm giving you again here 3 minutes or 2 minutes, I must say. Draw the diagram and try thinking. So in total internal reflection, what you need to be careful of, just before the question I want to discuss, what happens in total internal reflection? Like if there is a two media, suppose this is your N2, this is your N1, N2 is greater than N1. This refractive, this is denser, this is rarer. So if incident light is in denser media, what will happen? Refraction will happen then here, and it will move away from the normal because light is traveling from denser to rare. As we keep on increasing the angle of incidence, what happens? This angle of refraction will increase, and at certain angle, we get angle of refraction as 90 degree. And if we further increase the angle of incidence, it will come back to the same system. And that is your total internal reflection. I know that you already know. So for total internal reflection to happen, light must travel from denser to rarer, and there must be some minimum angle of incidence. And that for that minimum angle of incidence, angle of refraction needs to be how much? 90 degrees. So for if you are going to apply the Snell's law here, for minimum angle of incidence, that is called critical angle. So critical angle ke liye, angle of refraction become how much? 90 degrees. So this formula we use now. So these are the things. Now do it. 2 or 3 minutes you take. I'm giving you time, no worry. 3 minutes I'm giving. Aap karo and let me. Read the question carefully now. I'm here only. You can ask doubt if there is any. Then let me discuss. So what is happening here? There is a point source. This is source of light. Done. And this is placed at the bottom of a transparent block of height 10 millimeter. Done. Refractive index is given 2.72. It is immersed in a lower refractive index liquid. And its refractive index is what? Lower. Here given that N1 is greater than N2. Done. What is happening? It is found that light emerging from the block to the liquid forms a circular bright spot of diameter this. Why this spot is getting formed? First, the question is this. Done. So first you try to see how the light will come from this source to the liquid region. Done. So suppose I'm taking a single piece of light. This light is there. Then it is traveling at this point. Media is changing from this block to liquid. Then media changing, refraction will happen. Again, we are moving from higher media to lower media. It means denser media to rarer media we are moving. So there is a chance of internal reflection also, or may not be, depending on what is the angle of incidence. If angle of incidence is lower, if angle of incidence is lower than that of critical angle, what will happen? Light will go out. Then so for all this, light is going out. Several light I'm taking, they are going out like this. Then now what is happening? I am taking a light incident here at angle that is our critical angle I'm taking. So light will come like this. Then and again what I'm doing, I'm taking another incident light. Again, this is at angle incidence, angle of incidence greater than the critical angle. So what will happen? Light will come inside the cubical block. I'm not able to draw the diagram properly. So for if this is the block and this is the source, if angle of incidence is greater than critical angle, Prithvi, yes. So what will happen? Light will come inside. Then light will similarly in this region also same situation will happen. Light will come inside. So if light starts coming inside, then what will happen? No light is going out. It means this region will appear as dark. And through this region, light was going out. For this reason, if we are going to take normal and incident light, if we are going to take, then this angle of incidence is less than the angle of less than critical angle. So no internal reflection. Light will go out. And if light is going out, it means this region will appear as bright. Then so up to the region, internal reflection will not happen. That region will appear as brighter. And where the internal reflection will first happen, light will go like this. And after that, light will come inside and no, this region will become dark. So only bright region is this. From the region, light will go out. This is this region. So this is the bright spot. Done. So this is the logic of this question. Now, I hope you will be able to solve it. If not, tomorrow I will be picking this question again, but I hope you will be solving it. Done. Even if not, that we will do. Chalo, theek hai. So next class, again, we are going to do some very good questions. Done. And we will be touching lens portion. We will be touching some more mirror wala portion. And in the last, I have thought of discussing some YDSE wala thing, what important points we need to remember in order to solve the question from wave optics. Okay? So tomorrow, what is the solution of last question? Solution I'm not keeping here. I will be solving it only, but since the time is going up, but I can tell you the answer. Answer is your 1.36. I need to close the class because class will be starting again for chemistry or maths. I don't remember. Done. So the correct answer is 1.36 If you need the solution, previous one also I gave it. I gave to you to solve now. Answer was A and C. I have discussed all the things. I have given you the formula. I have given the values, everything. Okay. If it is not happening, try contacting me. I will be giving you the answer or solution by making it on the copy also. But I hope you will be able to solve this question. If not, in the next class also I can discuss. But yes, try solving it. Okay. So everyone take care of yourself and keep practicing the question. Stay motivated and keep doing your work. Don't take tension, only do the work. Okay. Bye-bye. Tata. Take care.